Hello everybody, my name is John Haley and welcome back to Thermodynamics Lesson 2. Today we'll be covering quality. Now, why is quality important? Well, when you're working with your thermodynamics diagrams, whether it's pressure specific volume, temperature specific volume, temperature specific entropy, you need, by the state postulate, two independent points to determine any property you have for that working fluid. That if I'm pure liquid or pure vapor, I need pressure and I need specific volume, temperature, specific volume, that type of stuff. If I'm on the saturated liquid line or saturated vapor line, there's only one point that can occur. For example, on the saturated liquid line, there's only one pressure where I'm at a saturated liquid at a specific volume or a certain temperature type deal. So if I'm at 100 degrees Celsius, there's only one pressure that I can be a saturated liquid, and that is atmospheric pressure, or about 100 kilopascals. Now if I'm at saturated vapor, there's also only one pressure that I can be a saturated liquid or saturated vapor at 100 degrees Celsius, again 100 kilopascals or atmospheric pressure. By stating saturated liquid or saturated vapor, you identify one of the properties. Now you only need to identify your pressure, your specific volume, temperature, or your entropy, etc. But that changes when you're inside the dome. Here you have liquid and vapor. Two properties exist at the exact same time. Therefore, and you'll notice, or by what I said, the temperature and the pressure do not change when you're inside the dome. So you need a second intrinsic property. That property is called quality, usually denoted by X. So what is quality? I'll answer that here. What is quality? Well, quality, again the variable X, is defined as the amount of mass, or the mass of the vapor you have per the total mass. So mass of vapor over total mass. Now the total mass is composed of the mass of the liquid plus mass vapor. So it's just the percentage, so quality is just the percentage of vapor you have that you formed, for example. So if I say my quality is 0.3, that means 30% of my total mass has turned into vapor. And that will tell you that I'm 30% along this line here. Where's my mouse? 30% along this line here. And I now know exactly where I am. I can find every single property I need. So let's find those properties. How do I find them? Well, first off, you have to know what are your properties at the saturated and saturated liquid and saturated vapor point. So saturated liquid, saturated vapor. So since pressure and temperature are constant throughout the entire process, they're really not helpful at all. What you need is your specific volume, your specific enthalpy, and your specific entropy at the saturated liquid point and the saturated vapor point. So specific volume is defined as V sub F. You can do this curly tail here to do specific volume, or you can do lowercase v. It really doesn't matter. Some people add like a little squiggle on top. Then you have specific enthalpy sub F, specific entropy subscript F. For saturated vapor, you have specific volume sub G, specific enthalpy sub G, and specific entropy sub G. Now the equations for quality are quality, I'll label it as equations, get us more space to work with too. Equations. So I have for my specific volume at some point along the dome, I have that specific volume is equal to the fluid plus the quality times the difference in the specific volumes. And I'll now explain. I'll write out H first. Equation for enthalpy, and the equation for entropy. Now, if I want to know how far along I am on this dome, well, if X is a percentage of my amount of stuff that I converted into vapor, well, then I can take the difference between these 2 points. I hate that. These 2 points, if I know the difference and then I multiply it by the quality, I know the amount that I've passed. For example, if this is 6 and this is 4 and I'm 30%, you do 6 minus 4 times 0.3. That should be 0.6. That means this change I'm 0.6 away from 4. Therefore, my, say, specific volume, because PV diagram, would be 4.6. So, and same thing for the rest of the properties. So let's do an example. All right. I'll use blue. Example. I have a fluid that's at 20 bar pressure, has a temperature that I'm not going to list because I don't actually know the temperature for 20 bar to be inside the dome. I have a, actually really don't matter, specific volume at the saturated liquid line is 1 times 10 to the negative 3 meters cubed per kilogram. Specific volume at the saturated vapor line is 6 meters cubed per kilogram. My quality is equal to 30%. So, what is my specific volume of my fluid? Well, I can use this equation. So, my specific volume is equal to 1 times 10 to the negative 3 plus 0.3, remember it's a percentage, times the difference, 6 minus 1 times 10 to the negative 3. And this becomes 1.8 meters cubed per kilogram. Alright, that means this is my specific volume for my fluid when my quality is 30%. Now, if I know where my specific volume of my fluid is inside this dome here, I can also determine, well, what's my quality? So, by simply solving this equation in reverse. So, example 2. My pressure is 15 bar for my working fluid. Temperature, 100 degrees Celsius. Specific volume of the fluid, we'll say is 5 times 10 to the negative 3 meters cubed per kilogram. Specific volume at saturated vapor is 4 meters cubed per kilogram. My specific volume at my point inside the dome is 2 meters cubed per kilogram. What is my quality? Well, simply solve that equation in reverse. So specific volume is equal to specific volume of the fluid plus quality times the difference between the two. Solve for quality, I get specific volume minus specific volume of the fluid over Vg minus Vf. Now, you'll notice I'm taking the if I have the dome here, these 2 points, this is Vf, this is Vg, this is V. I am doing this difference here divided by the total distance, or total difference, and I'll get the amount of percentage at which I've gone across this line towards becoming a vapor. And this is equal to my quality. So, here, let's plug in my properties. As I have 2 minus 5 times 10 to the negative 3 over 4 minus 5 times 10 to the negative 3 is equal to my quality, which is equal at 0.5. That means for this diagram, horrendous graph, this is my dome, here is my saturated vapor, here is my saturated liquid. Let's reverse that. This is my saturated liquid, this is my saturated vapor. I am halfway. Means half my mass has turned into vapor. So now you might notice, well, what if I'm at the saturated liquid line? Nothing's become vapor because I'm completely liquid. You are correct. Therefore, at the saturated liquid line, your quality is 0 because you haven't done anything. There's no vapor moving. There's no vapor being formed. So, well, then what if I'm at the saturated vapor line? Everything's become vapor at that point, so what should my quality be? Well, you guessed it, your quality would be 1 because everything's vapor, so your mass, your vapor, would equal the mass total mass formed. That is it for my video on quality. If you have any questions, please leave a comment below. Thank you. Have a wonderful day.